Today we're going to talk about something called the Pythagorean identity. Now the Pythagorean identity comes from the Pythagorean theorem. We know that as a squared plus b squared equals c squared, where c is the hypotenuse and a and b are legs of a right triangle. So if we look at this right here and we labeled a, b, and c of the right triangle we have right here, we can see that this coordinate right here is going to be a units, comma, b units, because that's how far up we go. But in a coordinate plane, we can, instead of saying a and b, we know that this is the x and y coordinate of that point. So x, comma, y. So over here we can say x squared plus y squared equals c squared. In this particular problem, our c is 1. So x squared plus y squared equals 1. Well, now going back to what we know with the unit circle, where x is your cosine value and y is your sine value, we can then rewrite this as cosine squared of theta, that's how you write it, plus sine squared of theta equals 1. And that is the Pythagorean identity. Cosine squared plus sine squared equals 1. Now, this is different. In here, you're squaring the angle and then taking the cosine of it. What we want is taking the cosine of the angle and then squaring that result. So we don't want this. And this works for any value of theta or for any angle. That if I do cosine squared plus sine squared, it equals 1. Now this allows us, this Pythagorean identity can be used to rewrite trigonometric expressions in equivalent reduced forms, because we always want to reduce our ratios. And the Pythagorean identity, this should be identity, allows us to convert between sine and cosine values without knowing the angle. Because if we know cosine, we can solve for sine up here, and we don't need to know what that theta is. So let's kind of look at an example that's done for us. We are in quadrant 4, and sine is equal to negative 24 over 25. And we can use that Pythagorean identity to solve for sine and cosine. So again, sine is negative 24 over 25. Please fix that misprint. And since we know the angles in quadrant 4, we know that cosine is going to be positive in the end. So here's your Pythagorean identity, sine squared plus cosine squared equals 1. And remember, it doesn't matter if you switch the order of these because you're adding. Well, we know that sine is negative 24 over 25. Then we want to get cosine by itself. So that's why we subtracted 24 over 25 from both sides, or added it. So then at this point, this, simplifies to that. And then when you take the square root of the top and bottom, you get plus or minus 7 over 25. And again, because we are in quadrant 4, we know cosine's positive. So the cosine is 7 over 25. So you'll notice that we did do some problems like this very early in the unit, and we drew up the triangle and solved it that way. This is just another way of solving those problems without drawing out the triangle. On the next page, we're going to do a couple, and it's going to make much more sense once we do these. So we are in quadrant 3, and the cosine is negative 3 over 5. What is the sine? So quadrant 3 means that my sine will be negative as well. So sine squared theta plus cosine squared theta equals 1. We know that cosine is negative 3 over 5. So this is going to be sine squared theta plus negative 3 over 5 squared equals 1. So sine squared theta plus 9 over 25 equals 1. And then we'll subtract 9 over 25 from both sides. These cancel. So we get sine squared theta equals 1 minus 9 over 25. Well, we want to rewrite this 1 as 25 over 25, so we have the same denominators. So sine squared theta equals 25 over 25 minus 9 over 25. So sine squared theta equals 16 over 25. And now when I square root both sides, this is going to give me sine of theta equals, square root of 16 is 4, square root of 25 is 5. And since we took the square root, it's going to be plus or minus. But like I was saying, because we are in quadrant 3, my answer, my value is going to be negative 4 over 5. Because in quadrant 3, sine is negative. All right, I'm going to do this one right here, the solo, and then have you try the last two. So we have sine squared plus cosine squared. Oops, I forgot my thetas. Equals 1. We know that sine is negative 1/2, so that's going to go in for sine. So negative 1/2 squared plus cosine squared of theta equals 1. So this is going to be positive 1 over 4 plus cosine squared theta equals 1. Subtract 1/4 from both sides. And I'm also going to change 1 into 4 over 4 because that will give me common denominators to go ahead and subtract. So then we get cosine of theta equals 3 over 4. And then when we square root both sides, we get cosine of theta equals the square root of 3 over square root of 4 is 2. And we are in quadrant 4. This should be plus or minus. But since we are in quadrant 4, my cosine value is going to be positive square root of 3 over 2. And if we think back at the unit circle, that should make sense because cosine of 330 degrees is square root of 3 over 2, and the sine value is negative 1/2. So we don't need to know the angle in order to find out these values. So go ahead and pause the video and try these two. If you need to rationalize the denominator in some of these, you might need to. But otherwise, go ahead, try it, pause it. Once you're done, unpause it, and you can see my work. All right, let's look at these. So for the pair one, you were given that sine was 9 over 41. And you can check my work, and we got that the cosine is negative 40 over 41 because we are in quadrant 2 and cosine is negative. So take a minute to check your work there. Now, when it comes to the team problem, it didn't have a perfect square in the numerator, but everything else still works out the same. Cosine was 13 over 30. So when I squared that, I got 169 over 900. And then worked my way through, I got sine squared equals 731 over 900. And when I took the square root of the top and bottom, The denominator, 900, the square root of that was 30, but 731 did not have a perfect square factor, so I couldn't simplify that radical, making this our final answer. So this is just another tool that you can use. Again, you can draw the triangle if you wanted to, but this is a tool that can maybe be a little bit quicker in some instances. So thanks for watching the video. Make sure to like it and subscribe.